Taylor's and Maclaurin's expansion with Lagrange and Cauchy form of remainder. The first is the Taylor's expansion. Taylor's expansion. Now here, the first is if f is defined, on a and a plus h, that means that this is a, this much portion is the right side of a and this is the left side of a. I am defining it here. Now this, wait a minute, yes, next is such that 1 f, the fn minus 1, this is the n minus 1, the derivative of a. That means suppose f has suppose 7 derivatives. Suppose this is f, f1, f2 up to so and so forth. So I am talking about the sixth, that is 7 minus 1. This is the, this is your function f, first derivative, second derivative, sixth derivative and the seventh derivative. Suppose it is the sixth derivative, that is 7 minus 1, is continuous on a and a plus h. देखो अगर एक कोई फंक्शन है उसके मान लो 7 डेरिवेटिव्स है, टोटल 7 डेरिवेटिव्स है, तो सिक्स्थ डेरिवेटिव मतलब 7 माइनस 1 वहां तक सारे क्या है, कंटिन्यूअस है, ये सारे क्या है, कंटिन्यूअस है. सेकेंड f, अगर मैं बोलूं कि f6 कंटिन्यूअस है, इसका मतलब उसके पीछे वाले सारे कंटिन्यूअस है. इफ आई से f6 इज कंटिन्यूअस, all the preceding f6 are all continuous. That is f, f1, f2, f3, f4, f5, all are continuous. Now fn minus 1 is derivable on open interval a and a plus h. That is f6 is derivable, f5, f4, f2, f1 and f all are derivable on there exists a theta belonging to 0, 1 such that f a plus h is equal to f of a plus h f dash a plus h square by 2 factorial f double dash a h cube by 3 factorial f triple dash a triple dash, it's triple dash, wait a minute, it's triple dash, third derivative I mean to say, this is the third derivative of a, and so forth up to your this h n minus 1 upon n minus 1 factorial f n minus 1 a plus rn. Now this rn has two forms. The first is the Lagrange form of remainder, Lagrange form of remainder. That is, it is of the form, Rn is of the form h to the power of n factorial fn a plus theta h. And the Cauchy form of remainder is Cauchy form of remainder is Rn is equal to hn minus 1 hn, wait a minute, this is hn upon n minus 1 factorial 1 minus theta to the power of n minus 1 fn a plus theta h. This is the Cauchy form of remainder. This is the Cauchy. See, what is the difference? This is same, this is same. This quantity h power is same, h power is only in the denominator. This is the change here and this is the change here. इतना ही change है, जहाँ जहाँ पे ये change है एक, और एक यहाँ denominator में change है, The rest all are same. So let's rub all this. Now we will see the Taylor's infinite series. For Taylor's infinite series, Taylor's infinite series. The concept is very simple. You just need to remember this. Rn tends to 0 as n tends to infinity. This is the most important point that you need to write. Then what happens is that fa plus h becomes fa plus h f dash a, the first derivative, h square by 2 factorial f double dash a, second derivative, plus h cube by 3 factorial f triple dash a, third derivative, so on and so forth, so on and so forth, the nth derivative, so on and plus so on and so forth, plus nth derivative is hn n factorial fn a, and it continues और ये चलता रहता है. Maclaurin's expansion. Now see one thing, एक चीज देखो, just this you need to see. See, in place of a and a plus h, you will write here 0 and x. In this place you will write x. That means this whole thing will be same, only there will be a difference that in place of a you will write 0 and a plus h you will write x. यहाँ पे इतना ही चेंज होगा कि a पे a के जगह पे 0 लिखोगे और a plus h के जगह पे x लिखना है और कुछ नहीं करना है. Now see, here we will come to this Maclaurin's expansion. F is defined on 0 comma x. See here a is 0 and a plus h is x. This is the point. Such that this x is of course greater than 0. You can see this side. Such that fn minus 1 is continuous on closed interval 0 comma x, and second fn minus 1 is derivable on open interval 0 comma x. There exists a theta belonging to 0 comma 1 such that now instead of fa plus h you write x. This is equal to f of 0 plus x f dash 0 plus x square by 2 factorial, because if a is 0 then h comes out to be x. So in place of h you will write x. h के जगह पे x लिखना है. F double derivative of 0 plus so and so x cube by 3 factorial f third derivative of 0 plus so and so forth plus so and so forth x to the power of n upon n factorial x to the power of n minus 1. Just a minute. X to the power of your n minus 1 upon n minus 1 factorial fn, this is n factorial, fn minus 1 0 plus rn. Now this is rn. Now now this Lagrange form of remainder. Now see one thing, Lagrange form of remainder. Now see here, in place of now Rn you will write x to the power of n upon n factorial fn theta x. See, compare with this. See, x to the power of n, I'm talking about this. Compare with this. X to the power of n factorial fn. A is 0, h is x. यहाँ पे h क्या है, x है, और a क्या है, 0 है. So this will come, and now for the Cauchy form of remainder, for the Cauchy form, just a minute, Cauchy form of remainder, it will be Rn will be equal to x to the power of n minus 1 factorial 1 minus theta to the power of n minus 1 fn theta x. Just see that one here. See this one here. See this one. The Cauchy x to the power of n x n minus 1 factorial 1 minus theta to the power of n minus 1 fn. A will become 0 and h will become x. h की जगह पे x लिखना है और a की जगह पे 0 लिखना है. So this is the thing. Now Maclaurin's infinite series. Maclaurin's infinite series. Now here you have to write Rn tends to 0 as n tends to infinity. This is the most important line. This needs to be written. So now your fx will be equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 second derivative x cube by 3 factorial f triple dash 0 the third derivative is 0, so and so forth. The nth derivative is xn upon n factorial f n 0 nth derivative, and this will continue. चलता ही रहेगा.